Well, welcome. In this video, I'm going to introduce us to kind of compare, well, not kind of, I am going to be comparing layer 2 and layer 3 addresses. Let's get into this. This is going to be a little longer video than normal. And everything we talk about here will become more understandable later. Okay, when we talk about these addresses specifically, but I wanted to introduce this concept. So let's see, let me use my pen here. So looking at this data link frame here with the IP header, so here we have our data link header and our IP header. And our data link header includes right here protocols like Ethernet. And in the Ethernet header, as we're going to see in a moment, actually has both a source and destination address. We're going to talk about what those are in a moment. What can be a source of confusion is at layer 3, we have the network layer, and we have the IP header. Okay? And it can contain IPv4 or IPv6 source and destination addresses. So what I want to do is kind of give you an introduction to understanding the differences in these addresses. When we talk about Ethernet in a later video, and several videos, and when we talk about IPv4 and IPv6 in later videos, these will become a little bit more understandable, the differences. Okay, so let me go ahead and erase that, advance the screen here. Do that. There we go. So let's first talk about the layer 2 address. Okay. So layer 2 address. So here we have our data link frame that also includes the data link header, and there's also a trailer, and also things like the network header and transport header, etc. But speaking specifically to the layer 2 address, also known as the data link address. The purpose of this address is to allow a data link frame, like an Ethernet frame, to be delivered from one network interface card to another network interface card on the same network. So this is key here. NIC card to NIC card communications on the same network. Okay, this is going to become more understandable in just a moment. Okay, there's both a source and destination data link address. The source address is assigned to the network interface card. Sometimes we call this a physical address because it's actually embedded on the NIC card, or if it's a Ethernet NIC card. So sometimes we call this a physical address. We'll come back to all this in just a moment. Let's take a look at what a layer 3 address is, also known as an IP address, either IPv4 or IPv6. The network address, whoops, didn't want to do that. Want to go back here. Here we go. Let me bring up the pen. Okay, that's better, do it that way. The network address, okay, is there again is both a source and destination address. The source address is the original source address assigned in software of the device, and the final destination is where this packet is being delivered to, either within the same local network or to a remote network. And I mentioned that these addresses are assigned in software, and that can be done either statically or dynamically through things like DHCP or Slack. And we'll talk more about these later. DHCP is for both IPv4 and IPv6. Slack is for just IPv6. But don't worry about that right now, okay? Let's take a look at a couple of examples and to kind of just at least introduce us to all this. All right, so let's take a look at a layer 3 address. So let me click on my, there we go, pen here. So this device here, the original source device, is sending a packet to the final destination. It has a network layer address, an IP address. So this is a layer 3 network address assigned either statically or dynamically to the device. So it has in the IP packet, any IP packet it sends, its source address will be associated with its own address. The destination IP address, and again, we're talking about layer 3, the network layer here. This is the final destination address, in this case, the web server. Okay, so this is an address that is going to be used to send this packet either to the device if it's within the destination device, whether it's in its own network or in a remote network. Okay. And one of the ways this network address is used is as each router receives this packet, it will examine the destination IP address. So when router R1 receives this packet, it will look at the destination IP address 172.16.1.99. It actually looks it up in something called a routing table, and we'll talk more about this later. But looking up this address in its routing table will determine where to send this packet next. And in this case, it's sending it to router 2. Router R2 will also receive this IP packet and go through the same process. It will look at the destination IP address, look it up in its routing table, and it will determine that the destination IP address is actually on one of its own networks, this network right here, and we'll forward it to the final destination. Okay, and again, this is going to become more clear as we talk about these different layers and different protocols separately. Okay, but again, the layer 3 address is all about sending it from the original source to the final destination. Okay, all right, let's clear that out. Let's go ahead now and take a look at layer 2 addresses. Okay, so layer 2 address. You see a lot of colors here. So a layer 2 address. The layer 2 address is, there's both a source layer 2 address and a destination address. The source address is associated, and we're going to see an example here in a moment, associated with this device's network interface card. So, as you can, what happened, this source address is good for from this host to, in this case, this router. Again, layer 2 addresses are about NIC card to NIC card communications on the same network. So the source NIC address or the source data link address, this one right here, is associated with this NIC card right here, the NIC card of this computer. The destination NIC or the destination data link address is associated with the NIC card of this router. So let me kind of make these arrows kind of like that. Okay, I know that kind of looks ugly there, so let me kind of draw that one more time. Okay, the source NIC address is associated with the NIC card of this device. The destination NIC address or destination data link address is associated with the network interface card of the router on this link, on this network. Okay, so, and this is only good to deliver the frame from this NIC card to this NIC card, and that's as far as it goes. When the router receives this data link frame, it will actually remove this header, leaves the layer 3 header alone, and it will actually, as we're going to see, let's go ahead and forward it to the next slide here. Okay. And what happens is it actually, so it decapsulates, removes this router R1, actually removes the old source and destination NIC addresses. So this gets removed and adds on its own source NIC, okay, for the source data link address, and the NIC address of the destination. Okay, so the layer 2 header, the source data link address and the destination data link addresses are that of the NIC card that is sending the frame and the destination NIC. So once again, the data link header, the layer 2 header, is only good for NIC card to NIC card communications on the same network or on the same link. Sometimes we also call those link local. All right, let's just finish this up here, and I'm going to take a look at an example. Okay, so here's the the last example here, similar to what we've seen already. We have the frame now using a destination NIC of the final destination, the source NIC of router R2. So R2 had removed the previous data link header and encapsulated the packet in a new layer 2 header with a new source and destination layer 2 addresses. Okay, and you know, this is going to become, you're going to understand why this is the case in the next chapter when we start talking about Ethernet. All right, so let's take a look at a couple of examples. Okay, so let's see how a device communicates with another device on the same network. Let's see what those addresses actually look like. So let's start off with the easy one. Okay, so the network layer, in this case an IPv4 packet header with IPv4 source and destination addresses. So as you can see here, the PC1 is going to send a packet to the FTP server. Okay, the source IP address is that of the source, so 192.168.1.10, and that's right here. Okay, now what we've divided the address up into both a network and a host portion. We'll talk more about that later, a little bit now, but more later. The destination server has an IP address 192.168.1.9, and we can see that here in the destination address. Now, there's something that you should notice, okay, or you might notice. Notice that both the source and destination addresses have something in common. What they have in common is the network portion of the address. And what is that network portion? Well, it's showing 3 numbers separated by dots with the host, the 4th number. Is that always the case? No. We'll talk about that in more detail later. What constitutes the network portion, what constitutes the host portion. It uses something called a subnet mask, but don't worry about that right now. All I want you to notice is that this host realizes that this is its network portion, okay, of the source, and this is the network portion of the destination, and that they're the same. So PC1 realizes that both the source itself and the destination, the FTP server, are on the same network. Okay, that being the case, clear this out here. That being the case, it says, you know what? I don't have to send the packet to a router. Okay, I can send it directly. We're on the same network. So because we're on the same network, the source NIC, the source address of the this is the source MAC address for those of you that may know a little bit about Ethernet. If not, don't worry, we'll get there. But the source MAC address or source data link address is that of the sender. The destination data link address, the destination MAC address, is that of the FTP server. Okay, because it's going from this device to this device directly. NIC card to NIC card communications in the same network. Why is it in the same network? Because this IP address and this IP address, the source and destination IP addresses, are in the same network. All right, let's take a look at another example when they're not in the same network. Okay, so here we have two devices in two different networks. So let's take a look again at PC1. And its source address, its IP address is 192.168.1.110. Okay. The web server in this case has as you can see right here, has an IP address 172.168.1.99. The network portions of these two devices, and let's not worry how it figures this out. We'll talk about that later. But notice that they are different. So PC1 here says, you know what? I can't get there directly. I have to send this packet to a router, my local default gateway. Kind of like taking a letter to the post office when it has to be delivered to somebody outside your neighborhood. All right, so let's take a look at what these addresses look like. Now, the source and destination addresses, okay, those are going to remain the same. We'll talk about something called network address translation a little later, okay? But suffice it to say that these are the addresses used to deliver the packet from the original source to the final destination. Let's take a look at the data link header. In this case, the Ethernet addresses, MAC addresses. Once again, the source address is that of PC1's network interface card. Okay? But notice the destination MAC address. It is not that of the web server. Notice it's that of the router, and actually the router's NIC card on this link, the same network as PC1. Again, the data link addresses are for NIC card to NIC card communications on the same network. When router R1 receives this Ethernet frame, and it notices that this destination address is its NIC card, so it says, okay, this is for me. It will actually remove this header. It will then look at the destination address in its routing table, find out where it sends it next, and will actually encapsulate this packet. I'll put packet here in a new data link header and trailer. And depending upon the medium here, we'll talk more about this later. Let's say it is Ethernet. Okay, we'll put a new source and destination Ethernet MAC addresses. The source will be the NIC card. I'm making this a little sloppy here, but will be the NIC card on that link, and the destination data link address will be the NIC card of that router. Okay, these addresses, let me kind of clear this up a little bit here so I can, when I circle things, you can see it. This frame, this protocol, this header is only good for NIC card to NIC card communications on the same network. It is removed by the router, and the router creates a new one to send it from this NIC card to this NIC card. Okay, in this case, router R1. Router R2, when it receives the frame, will remove the data link header created by R1 and the trailer, and create a new one with the NIC card, with the data link source address, the address of its NIC card, and the data link destination address, that of the next hop router. And then and send it on to I guess we have R3 here. Don't have it labeled. Okay, and then when R3 gets it, it will do the same thing. Remove the data link header and trailer and send it um, onto the device. This is an Ethernet switch, by the way. We'll talk more about that a little later. All right, so I hope that makes sense to you. If you're still a little fuzzy on it, don't worry. We're going to cover this in more detail when we get into Ethernet, and again when we get into IP. So it'll become more understandable, and you'll see the differences of how these addresses are used and why we even need these Ethernet addresses. We'll talk more about that when we get into Ethernet. Okay, so if you have any questions, please be sure to ask me in class or send me an email or whatever we may need to do. Okay, this is, oh yeah, I do want to finish something else up. You might be wondering, how does a device know the layer to the destination address? So you may be wondering, before I finish this up, you may be wondering, okay, this device here knows its own source data link address, its own Ethernet MAC address, but how did it know the destination? Or you might be wondering, the device knows its own IP address. How does it know the destination IP address? Don't worry, we're going to talk more about both those things later. The more we learn, the more questions we have, right? Okay, so hang in there. This will all become clearer as we go through both Ethernet and IP individually.